Hello everyone, welcome or welcome back to my YouTube channel. Let's continue solving Leetcode with Leetcode 26, remove duplicates from sorted array. So we are given an integer array norm sorted in non-decreasing order, and that just basically means increasing order like one, two, three, four. So like non-decreasing because it is increasing. And we want to remove duplicates in place. We've solved a number of these problems. I'm going to link in somewhere around that says we've solved that uses this particular phrase to do something in place. And we've talked about the main technique when you see a problem like this, just using two pointers, which we will see during the algorithm and the problem walkthrough, such that each unique element appears only once. The relative order of the elements should be kept the same, and then we want to return the number of unique elements in norms. So again, for instance, if we have this array of 0, 0, 1, 2, and 4, this is non-decreasing, and we want to remove all duplicates. So we're going to be left with just one zero, and so 0, 1, 2, 4, and return the length of this new array, which is going to be 4. Now let's look at our problem walkthrough and how we might solve this problem. So I'm going to write an array. So we have an array that basically contains this value, and we want to return the unique ones in place. So what are we going to do? We're going to use two pointers, left and right pointers, to basically check for whether we've encountered this value before. So I'm going to start with a left pointer, which is going to be channelized to the index 0, the first item in our array, and then a right pointer, which is going to be on the second index of the array. And what we want to do is we want to compare if these values are similar. So if these values are similar, what can we do? I'm going to give you a minute to think about it. Technically, there is something that we can do, but in this case where we are not using an extra space or anything like that, the best we can do is to replace the value with a more unique value and to completely ignore it. So now we have two zeros. We can't just remove it. We can't just use splice that uses an extra space that complicates the entire thing. Basically uses an extra space, and we asked to do this in memory. So what we want to do is we want to then continue down our array and look for unique values that we can replace that particular index with. Again, if you are not sure about what two pointers is, I really encourage you to watch the previous videos that we done on this subject. We treated them in depth, but you can continue with this one because I still plan to go in depth. Anyways, so we have the left and right pointers. When we have values that are the same, we really do nothing. However, we move our right pointer. So now our right pointer goes from here, and then we move it to the next value in the array. Now we check our left pointer and our right pointer, are they the same? This time they are not. So our left pointer is kind of going to keep track for us the unique values or non-unique values that we've seen. It kind of is on the lookout for us. That is what our left pointer does. But our right pointer, on the other hand, is going to be the one moving around and then finding the values with which we are going to compare our left pointer to. Now, when we find a unique value, what do we want to do? We're not going to go right ahead and then just swap it out. It is straightforward to just replace the value of the right pointer, and then we have that value at the left pointer. Now, this is easy to do, and this is also a good answer if we are removing values that are not unique. However, we are asked to return it in place. If we do this, now we're going to have 1, 0, 1, in which case this will be wrong because our array is expected to be non-decreasing. So we still want to return 0, 1 instead of 1, 0, 1. So we would not be changing the values immediately we encounter them. Instead, we'll be increasing our left counter and then replacing the value rightmost to our left pointer with the unique value we found on our right pointer. I feel like you might need a minute to pause this and think it through, or draw it on a paper if it's not clear. So essentially, we are saying that recall where we started from. We started from left pointer, right pointer. We want to see unique values. We encountered a duplicate value, but essentially, the best thing we can do is to overwrite duplicate value. So we move on with our code. And when we encounter a value that is not duplicate, we then go ahead and replace the rightmost value, which is this, with the non-duplicate value that we've seen, which is 1 here. So 1 now comes here. Then we also move our left pointer. We move our left pointer right to this index that we are, and our right pointer, we also move it from here to this place. So we've already dealt with this. This spot is basically empty because we already replaced the value from this index to this index. So we continue traversing. Now we check our right pointer. Our right pointer, is it the same value that we have in our right pointer that we have here? Yes, it is. So what do we do? Actually, we do nothing. Recall, we only do something if we encounter different values. But if we encounter a value that is the same with where our left pointer currently is, we just move on. So we move on from here, we move on to the next value here. We check again the value in our right pointer. Is it the same value in our left pointer? Yes, it is. So we move on to our next value, next pointer, next value in the array, which is 2 at this point. Now we check, is our left pointer and our right pointer the same? No, it is not the same. So what we do then is, giving you a second again. Yes, exactly. We replace the index to the right of our left pointer with the um next unique value that we've seen. So this is where our left pointer currently is. The rightmost value to it is here, and we replace that with 2. And 2 now is basically empty. So far we have 0, 1, 2. Now we once again finally move our left pointer from here to the next value that we just changed, and we also remove our right pointer to the next value. Now we check, is it unique? Do we, as our left pointer and our right pointer, is it the same thing? Actually, no, it's not the same thing. So what we do in this instance is we replace the value to the rightmost of our left pointer, which is this. We replace it with the value at our right pointer. So now 3 is basically empty now, and it comes here, the value that it is rightmost of our left pointer. Recall our left pointer is here, the value that is on the rightmost here, so we replace that value essentially. And what is the next thing that we do? We move our left pointer to, when there is a change, when there is a swap, we move our left pointer, and also remove our right pointer to the next value. And yes, you know what is coming. We compare left pointer, right pointer. Are they the same? Yes, they are the same. In which case, we do what? Right, we ignore. And then we move on to the last value in our array, and then we compare, is our left pointer, is the value at our left pointer and at our right pointer the same thing? No, they are not. So what do? We replace the value to the rightmost of our left pointer, which is this. So we replace that value with 4, and there is nothing else to traverse, and then we are done. Now, what do we return? So we want to return the length of our new array, which is the number of unique elements that we have found. So right now, we are taking stock of the number of times that we move our left pointer, which is 1, 2, 3, 4. So we moved our left pointer 4 times. However, the length of the array is going to be the number of times we moved our left pointer plus 1. And we're checking the number of times I move our left pointer because we only moved our left pointer when we found a unique value, if you recall. And also our index starts from 0. Our array is basically 0 based, but the length is not going to be 0 based, if that makes sense to you. So although we are doing 0, 1, 2, 3, 4, the length of the array is actually going to be index plus 1. So that's why we're having 4 plus 1 to get the length of our new array with unique values. So for our complexities, our space complexity is constant. We were asked to do this in place. So by default, we have to use a constant complexity with no extra space. And for time complexity, this is linear because our code runs for as long as is the length of the array. Now let's jump right into our code. So let's jump right into our code. First, we want to define our pointers. Our left pointer is going to start at index 0, and we want to define our right pointer, which starts at an index of 1, and our code is going to run for as long as is the length of our array, and we are going to increment that basically. So our right pointer starts at index 1 because we want to compare the previous value at index 0 with the current value at index 1. So basically from the code walkthrough, we are comparing left and right, and we are saying that if both values are the same, we don't want to do anything. We're just going to ignore it. However, if it is not, if our value at the left pointer is different from the value that we have at the right index, we want to go ahead and increment the rightmost value. So what we have to the right of our left pointer. So left pointer plus 1 is basically what we have. We want to store the value of right in that space essentially, and then we increment our left pointer. In the end, we want to return our left pointer plus 1, which is going to give us the length of the array. Now let's submit that. We've discussed the complexities, and yeah, we can see that this gets accepted. Great. I hope this was helpful in some way. Please leave some feedback, like, comment if it was helpful at all, and I'll see you in the next video. Bye.